So now it's an electrical energy, 43.2 joules, as opposed to being mechanical energy. But we can think of this as if this was a particle that we were talking about. So say that this 10 microcoulomb charge is on a dust particle. And let's say that that dust particle has a mass of 10 micrograms. Seems. Then we could say, well, that mass then in kilograms will be 10 to the minus 9 kilograms. So micro is 10 to the minus 6 grams. So if we had that as our mass, well, now we can look at this equation, which equates the amount of energy that we have. And if we were to let this particle go, it's going to start shooting off that way because it's going to be pushed away by this one. Moreover, it's going to be pushed that way, and by the time it gets to this location right here, it will have given up all this energy. This energy will all have turned back into kinetic energy, and it will be moving at that speed. So we can take this equation, that's kinetic energy from back in the fall semester. This is the electrical energy we just calculated. So say we have 43.2 joules here equals 1/2 10 to the minus 9 kilograms, and then V squared, or unknown as V. We come over here and say, okay, well then that means that this is 86.4 times 10 to the 9. And if it's 86.4 times 10 to the 9, is that right? Oh, I said 10 micrograms, so it's 10 times 10 to the 9, minus 9. I'm sorry. Okay, which means it's to the minus 8. That's why my numbers there didn't match up. Okay, so this is 8.64 times 10 to the 9. That's equal to V squared. And the square root of that is going to give us roughly 92.9 times 10 to the 3 meters per second. So that's the velocity that that particle would have when it passed by that position where it was earlier. Now, if we said, well, how fast would it go if we just let it go all the way that it could? Well, we would then need to look at, well, how much energy does it have when it's right here in comparison to this as well? We could look at what we're doing now is looking at how much velocity would we give it because of the fact that we pulled it to right here. It's going to continue on that way, and it's going to continue to pick up energy because of the fact that there's a charged particle over here. Continue to push it away.